Hi guys, in this video, I will discuss some of the properties of the subatomic particles. So we already know that there are three fundamental subatomic particles out there: the protons, neutron, and the electrons. And these subatomic particles right here are very tiny, and clearly we cannot see them. Even with the latest technology that we have, we cannot see the subatomic particle. We may be able to see a blurry picture of an atom. But now an atom consists of even the much smaller subatomic particle, and we cannot see them. And because these subatomic particles right here are very tiny, their mass are also very small as well. So therefore, we invented a new unit to express the mass of the subatomic particle. And this unit right here is called this atomic mass unit. And it is abbreviated either with AMU or U. So they both mean the same thing, the atomic mass unit. And the atomic mass unit was defined using the carbon-12 as the reference. And so it being defined in such a way that one atom of carbon-12 would have the mass exactly equal to 12U. And in order for a carbon-12 to equal to exactly 12U, 1U or one atomic mass unit would then equal to 1.66 times 10 to the negative 24 gram. So that's how the atomic mass unit is being defined, equal to 1.66 times 10 to the negative 24 gram. And please remember, since this value right here comes from definition, therefore it has infinite amount of significant figure when we use this value in calculation. And here is a summary of some of the properties of the three subatomic particles. So first, the proton. The symbol of the proton is P, and because the charge of the proton is positive 1, so therefore we put this plus charge right next to it. So that will be the symbol of the proton, and the charge is positive 1. As for the neutron, its charge is neutral, and therefore its symbol is simply this N. And as for the electron, its charge is negative 1, and its symbol is E, and because it is negative 1, therefore we put this negative charge right next to it. So those are the charges and the symbols of the three subatomic particles. As for the mass of this particle, the protons is 1.673 times 10 to the negative 24 gram. As you can see, this is a very tiny value right here. And as for the neutron, its mass is 1.675 times 10 to the negative 24 gram. So quite close to the mass of the proton. And the mass of the electron is 9.109 times 10 to the negative 28 gram. So we can see now the mass of the electron, it is much smaller than the mass of the proton and the neutron. So negative 28 versus negative 24, we can see that both the protons and the neutron are about 10,000 times heavier than the mass of the electron. And when we convert these masses right here into the atomic mass unit, they equal to the following. The mass of the proton is 1.0000728 AMU, and the mass of the neutron is also about 1.00867 AMU, and the mass of electron is 0.0000545 U or AMU. So again, we can see that this is about 10,000 times smaller compared to the mass of the neutron and the proton. And as for the location of where we will find these subatomic particles in the atom, then the protons are actually found inside the nucleus of the atom. And for the neutron, same thing, it is found inside the nucleus. And as for the electron, they are outside the nucleus. So the proton and the neutron basically make up the nucleus of the atom. Thus, we can see that the mass of the atom actually it condenses inside the nucleus, because this is where we will find bigger and heavier subatomic particle. And here are some of the properties of the subatomic particle. So the charge is actually a very fundamental property of the proton and the neutron, because proton are positively charged and the neutron is neutral and the electron is then negative. So therefore we can see that the proton and electron would actually attract each other if they were to come close together. So let's say here we have a proton which is positive and the electron that is negative. When we bring these two particles closer together, they will attract each other and come in close together. And similarly, when we have like particle, and by like particle we refer to proton and electron, then we will then see that proton will repel all the proton and electron would repel all the electron. So if we would have two protons close together, they will repel each other, so they would come out apart from each other. And similarly with the electron, if we take two electrons and we put them close together, they will also repel each other as well, and now they are much further apart from each other. And because the neutron are neutral, therefore proton and electron neither repel nor attract the neutron. So please try some of this practice problem right here and learn of this new unit right here, yocto. And so this is a new SI prefix that we are learning in this. So please figure out what a yocto is.